Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. As indicated, today we are going to revise paper 2, chemistry. So I felt that it's important that we first look at how the learners have been performing in this topic in the previous year. You will have seen that here, question 1, learners were performing at 51. Remember, question 1, we're talking about multiple choice questions. So learners were performed at 51%, question 2 at 65%, question 3 at 60. Remember, question 2 is your naming and isomers. We refer to it as nomenclature. And then question 3, that is your physical properties. Remember, learners, we do 3 physical properties, which is your melting point, your vapor pressure, and your boiling point. And then in question 4, we're talking about reactions of organic molecules. Learners performed at 49%. You can see the performance in terms of reactions goes down. Question 5, which is rates of reactions, is at 47%. Question 6, which is at 52%. That is chemical equilibrium. And then question 7, 41%. That is acids and bases, 41%. But look at question 8, which is your galvanic cell. The performance was at 27%. You can see a huge drop there in terms of galvanic cells. I know you have done them not long ago. You still remember them. We'll definitely prioritize galvanic cells. We'll prioritize as well question 9, which is your electrolytic cell. This is the last question of your paper, and most of learners don't really do well in this last question. So we'll ensure that after this, you must be even more confident to go and write these questions or come Monday. On average, learners performed at 49%. So now, the first topic, without wasting time, which is our organic molecules. As indicated, we are going to start with nomenclature, which is your naming of organic molecules. I hope by now you must be having confidence in terms of naming of organic molecules. So we'll look at that. Our focus would be on skills, so that whatever you are given, you are able to name. It doesn't matter what question is about. As long as you say name, write down the IUPAC name of an organic molecule, you must be able to name that organic molecules. We'll as well look at isomers. So we'll do naming and isomers as well. And then we'll look at physical properties. I've already indicated that we focus on 3 physical properties, which is your melting point, your vapor pressure, and your boiling point. So those are the 3 physical properties that we do. So we're going to look at the factors that affect these 3 physical properties. And then we're going to look at that, and then we're able to move. So I hope you will, when you leave this lesson, you'll be happy and be able to go and write question 3 and get all the marks that you can collect. Nothing is difficult here. You just have to have a conceptual understanding. And then we're going to look at organic reactions. Now, it's very much important when you look at reactions of these organic molecules. I think it's of importance that you check which organic molecules undergo which type of reactions. You will remember our organic molecules is made up of only 9 homologous series. So we have 9 homologous series, which is your alkanes, alkenes, and alkynes. I always refer to them as AAA, which is your alkanes, alkenes, and alkynes. And we refer to them as hydrocarbons. So those are our hydrocarbons. So it's important that we have that. And then we have what I refer to as Hake. And then your Hake, we're talking about your haloalkanes, your aldehyde, your ketones, and your esters. And then we have the last 2, which is your alcohols and carboxylic acid. So you can see we have 9 homologous series that we are going to focus on. In terms of grade 12, those are the only 9 homologous series we have to know. So alkanes, alkenes, alkynes, haloalkanes, aldehyde, ketones, esters, alcohols, and carboxylic acid. And we are saying when it comes to reactions, organic reactions, it's very much important that you understand which homologous series will undergo which reactions. So we're going to look at that to say if we're having this type of homologous series, which reaction will they undergo. And I will want to advise you to give a special concentration to 3, your alkanes, I refer to them as AHA so that you don't forget. That is your alkanes, your haloalkanes, and then your alcohols, haloalkanes and your alcohols. You will see that most of reactions are around these three homologous series. So it's very much important to understand that when I see an alkane, when I see a haloalkane, when I see an alcohol, which reaction will they undergo? So we're going to look at that. Hence, I'm emphasizing there to say, always have that in your mind, to say, when I'm having alkanes, when I'm having haloalkanes, when I'm having alcohols, what type of reactions? You will see that all of them, they can undergo what we refer to as substitution. So when you see alkanes, haloalkanes, and alcohols, you know that they can undergo a substitution. And all of them can undergo eliminations. They can all undergo elimination. So it's very much important. You will see that most of the questions that we'll have under reactions will be based on this AHA that I'm referring to, or your alkanes, haloalkanes, and alcohols. They will definitely undergo substitution. They will definitely undergo elimination. And then we want to emphasize the issue of reaction condition. Remember, for a reaction to take place, the condition must be met. I know you have done rates of reactions. You know that there are conditions for a reaction to take place. You said there must be correct orientation. There must be enough kinetic energy. Even in terms of these reactions, it's the same thing. We are saying now there are reaction conditions. So know the reaction conditions, and then they will be able to tell what type of reaction will take place. So I'm emphasizing that as long as you want to get many marks in this topic, you will definitely understand the reaction condition. I think I've emphasized that enough, and then you understand the importance of reaction conditions. If you know reaction conditions, you will know the type of reaction that will take place, and then that will definitely help us. Now, in terms of question 2, we are saying we have these definitions that you must know. I know by now you must be singing all these definitions. You know, for definitions, we are saying you must know them according to the exam guideline, so that you get all the marks that are allocated. For example, the first definition there that I gave there is homologous series. To say what are homologous series, you remember you are saying is the series of organic molecules that can be described by the same general formula. They can be described by the same general formula. Or you can say each member differs from the next by the CH2 group. So you will talk about that as you define homologous series. And then you must be able to define as well the functional group. Remember, we're saying this one are the centers of reaction. These are the centers of reaction. When you talk about physical properties, which is your melting point, boiling point, and vapor pressure, they will definitely depend on the functional group to say in which family do you belong, because how the homologous series is going to behave is going to depend on the functional group. So functional groups are important, and we are saying these functional group these are the bonds. Remember, we have alkene, that is a double bond. We have an alkyne, that is a triple bond. So you see that a functional group can be a bond. And then it can be an atom. It can be an atom, can be a bond or an atom. A bond or an atom. And then it can be group of atoms as well. They are able to indicate a functional group. So that back is just for you to remember that it can be a bond, it can be an atom, it can be group of atoms that determine the physical and chemical properties. Physical, question 3. Chemical, question 4. So we're saying how the reaction, how the homologous series or how organic molecules will, how fast they boil or how slow they will boil or how high their boiling point depends on the functional group. So it's very much important. And we're saying a functional group is a bond, is an atom, is a group of atoms that determines the physical. Question 3, it determines the physical and chemical. Chemical is question 4, the reactions. How they react, it will depend as well on the functional group. So we're saying it's a bond, it's an atom, it's a group of atoms that determine the physical and chemical properties of an organic molecule. So you are able to get that definition as well. Remember, when I started, I said AAA, we're having our hydrocarbons, alkanes, alkenes and alkynes. Please don't forget that as you prepare yourself for this topic. Alkanes, alkenes, and alkynes. These are hydrocarbons. Why do we call them hydrocarbons? We're saying these organic molecules are made up of hydrogens and carbons only. Hydrogen and carbon atoms only. So it's only hydrogens and carbon atoms only that makes up a hydrocarbon. And we're saying these hydrocarbons, they can be saturated or unsaturated. So the hydrocarbons can be saturated or unsaturated. So you are able to know that when we say they are saturated, we are saying they have no multiple bonds between carbon atoms. Please, always let's use the definitions from the exam guideline. When we say saturated, we are saying they have no multiple bonds between carbon atoms. When we say unsaturated, your alkenes and alkynes, they are unsaturated, which means that they have a double bond between carbon atoms. So be able to differentiate between saturated and unsaturated. And our exam guideline has made it much easier because we're saying saturated have no multiple bonds between carbon atoms. Unsaturated have multiple bonds between carbon atoms. But don't make a mistake of just saying saturated, they have single bonds and you leave it there. Unsaturated, they have double bond or triple bond and leave it there. No, you must be able to say saturated have no multiple bonds between carbon atoms. Underlined the between carbon atoms because that double bond must be between carbon atoms. For it to be unsaturated, the double bond or triple bond must be between carbon atoms. Now, when we are done with that hydrocarbons, which is your alkenes and alkynes. Remember, alkanes are saturated, which means they have no multiple bonds between carbon atoms. Now, we're going to look at the isomers. And for isomers, we are saying these are structural isomers. They have the same, iso means same. They have the same molecular formula, but different structural formula. So we're calling them structural isomers. And then we're saying we have three types of structural isomers. We have three types of isomers, which is the chain isomers, the positional isomers, not position, but positional isomers, and the functional isomers. So these are our isomers that we are having. To say now, always these are organic molecules. So you will just say they are organic molecules with the same molecular formula. All of them isomers, they have the same molecular formula. What is different? For chain, the different chain length. So different chain length or different types of chains for chain isomers. And then for positional isomers, same molecular formula but different position. Please remember the different position is three things that have different position. I know that you might be used to say they have the same molecular formula but different functional group. No, you must mention all the three of them. They have the different position of the side chain, of the substituent, and of the functional group. Please write the correct definition according to the exam guideline. So please ensure that for positional isomers, we're saying the organic molecules have the same molecular formula, but different position of the side chain, of the substituent, and of the functional group. Please, SSF, remember always that. Now, and then you will see that the chain isomers and positional isomers are within a homologous series. So when you have the same homologous series with different chain length, you know that we are talking about chain isomers. When you have the same homologous series with a different position of either the side chain, the substituent, and the functional group, we're talking about functional isomers. And then, we're talking about positional isomers. So when it comes to functional isomers, they belong to different homologous series. So the homologous series are not the same. So we're saying these ones, they have the same molecular formula, but different functional group. They have different functional group. And we gave you cake there for you to always remember to say these ones is between the aldehyde and ketones, the carboxylic acid and esters. I hope this helps you as you remember the definitions, because definitely you will get questions that want you to define. I think I've laid the ground we can go now and look at questions to say how do you go about answering questions. For example, this one is saying which one of the following is the general formula of alkanes? Now, we have 9 homologous series. The expectation is that you must know all the 9 general formulas for those 9 homologous series. Please ensure that you know all of them. We had alkanes, alkenes, alkynes, haloalkanes, aldehyde, ketones, esters, alcohols, and carboxylic acid. And we are saying to you, know for alkanes, for example, know that alkanes is CN H2N plus 2. So we have everything. That is the richest one. If you look at alkanes, they have maximum number of carbons and hydrogens. And then when it comes to alkenes, we are saying now for alkenes, we're going to remove 2 hydrogens to form alkenes from alkanes. Then definitely it will be CnH2n. And then for alkynes, we remove another further 2 hydrogens, then it becomes CnH2n minus 2. Haloalkanes, we are removing, or we are substituting one hydrogen. You know the reaction substitution. When you substitute 1 hydrogen by a bromo or a chloro, a group 17 element, so you get a haloalkane. These are alkanes of special kind because they have halogens. So it's a haloalkane, and then we're saying a haloalkane, it will still be CnH2n plus, but it won't be plus 2 because we are removing 1 hydrogen. So it will be plus 1, and then where the halogen is, we put X. Remember, X stands for halogens, hence we call them haloalkane. So you just look at the alkane, CnH2n plus 2, you remove 1, then we have CnH2n plus 1, then you put X for halogens, and then that is our haloalkanes. And then when it comes now to our aldehyde is now CnH2nO. So you can see that we are removing 2 hydrogens from the alkanes. We are putting 1 oxygen, which shows you that there must be C double bond O there. There must be C double bond O in aldehyde. And then ketones as well. Ketones, it will be CnH2n. Don't forget the N there. Is CnH2nO. So you can see that the general formula for aldehydes and ketones, it is the same. Definitely is a message to yourself. Hence, we are saying aldehydes and ketones, they are functional isomers. As long as they have the same molecular formula, they will definitely be functional isomers, because you can see that. And then we have what we refer to as esters. And for esters, we are saying now we're talking about now 2 oxygens, CnH2nO2. The same with carboxylic acid is CnH2nO2. So what am I saying? I'm saying that alcohols, they have CnH2n plus 1 OH. Don't forget the 1. Because Leonard just write OH and it becomes wrong. So those are general formulas, and definitely the expectation, you know all of them, because one of them, if you find any question that want you to use that, you are able to do that. Remember, when we give you the number of carbons, you can come and substitute N there to get the molecular formula. So you are able to move like that. I hope that helps you and reminds you, because this is the foundation that you are building these organic molecules on. So if you don't know the general formula, which is now the basic building block in terms of these organic molecules, you will have a problem. Make sure that you understand all those general formulas. And then the question was for alkanes, and then we know that for alkanes, it must be CnH2n plus 2. So CnH2n, we said is alkenes, because we have removed 2 hydrogens from the alkanes. CnH2n minus 2, we said is alkynes. And then CnH2n plus 2 definitely is an alkane, is saturated. And then CnH2n plus 1 OH. So you can see there you have your alcohol. So you are able to know all the general formula. I've emphasized that as I move. I hope you have that, and you will definitely go to the exam with all the general formulas. Now, for question 2 there, is about functional groups, because as well, you know the general formulas. The expectation is that you must know all the functional groups. These functional groups, some have names, and then the ones that have names are the ones that are in this question. So this question, I like it because it's showing you that these are the functional groups that have names, and the expectation will say write down the name of the functional group. Now the question was name of the functional group of alcohols. So this question is based on alcohols. And then you are able to come and check this one. A is carboxyl group. You can hear from the name carboxyl, it means it's a functional group for carboxylic acids. So we just took the carboxyl there. And see, all the functional group have a group because they are groups. We call them functional group, which means for carboxylic acid, you will call it carboxyl group. For carbonyl, you have carbonyl. Carbonyl, we have it in ketones. I usually call them the ketones. And then you are able to say, okay, carbonyl will get it in ketones, and then formyl group, you are getting them in aldehyde. Please know all the names of these functional groups. For aldehydes, we call them formyl or formyl group. Hydroxyl group for alcohols. Now, the other question that you can be asked there is to say, draw the structural formula of the functional group. So you must be able to know how to draw the structural formula. Structural formula means show all the bonds of the carboxylic group. So you must be able to show the C double bond O with an OH. Remember, carbon must have 4 bonds around it at all times. Please don't forget. All the time for carbon, there must be 4 bonds around it. We said it's tetravalent, it's group 14, so you know definitely that it must have 4 electrons there. Now, again, the other thing which is important is the oxygen. That oxygen at all times must have 2 bonds around it. Carbon, we're saying all the time 4 bonds. Oxygen, all the time 2 bonds. So when you're throwing oxygen, it will always have 2 bonds. And the hydrogen will always have 1 bond. So don't forget that. So when you are drawing your carboxyl group, definitely your carbon, ensure that it has 4 bonds around it. And it has a C double bond O and an OH. I usually refer to it as Cu, so that you always remember. And we are saying the name of this functional group is called carboxyl group. For ketones, we said the name of the functional group is called carbonyl. And the carbonyl, when you draw it, it's a C double bond O, but this C double bond O is surrounded by 2 carbons. It must be between, for ketones, it must be between 2 carbons. For aldehydes, it must be a C double bond O again. So you can see what is common here, C double bond O. And then this C double bond O must be followed by the H there. So you can see there that now it's no longer between 2 carbons. It's on the terminal carbon. It's in carbon number 1, the C double bond and then H. And always the carbon must have 4 bonds. Please know how to draw this structural formula. Many exam question papers have that question. Now alcohols, there are learners who make a mistake of thinking that alcohols are OH. Alcohol, the functional group is not OH, but the functional group is the carbon bonded to the OH like that. So please, when you say draw the structural formula of the functional group for hydroxyl group, for alcohols, definitely it must be carbon. So you can see there is something in common. All these functional groups, they have carbon. There must be carbon, and then the other part of the functional group. So this is what we refer as hydroxyl group, the functional group, and this is the structural formulas. I hope this assists you as you go on with the questions, and then you understand. Now, here the question was about alcohols, and already we said that's how we draw it, and alcohol is hydroxyl group. And you can see it's hydr from hydrogen, Hydrogen with what? With oxygen. So you can see hydroxyl group. I think it helps you now to see that, okay, it's a hydroxyl group for alcohols. Now, as we move, because we want to do as many questions as we can, we are saying which one of the following pairs of compounds are functional isomers? When you see functional isomers, you always remember cake, that we have the carboxylic acids and esters. We have the aldehyde and ketones. And remember, carboxylic acids and esters, they have two oxygens. So CnH2nO2, CnH2nO2. So I always emphasize this EC. Some they say Eastern Cape for them to remember. EC, you know that is for esters and carboxylic acid. They have two oxygens in them. So when you see two oxygens within a structure, you know it's either an ester or a carboxylic acid. And we are saying for a carboxylic acid, the C double bond O and the OH is in carbon number 1. So it's easy to identify carboxylic acid because the Q or the C double bond OH will be in carbon number 1. But for the ester, the C double bond O and another oxygen will be surrounded by those carbons there. So you're able to see the difference, to say these ones, C double bond O and an oxygen must have carbons around. But for carboxylic acid, it's a C double bond O and an OH. So the H there that is bonded to the hydrogen is the one that is showing you that this is a carboxylic acid. So all the time, remember EC, they have two oxygens and can only be esters and carboxylic acid. And then we are saying the structures that have one oxygen is your alcohols, your aldehyde, your ketone, and alcohols. These ones, they have one oxygen. So you can see already that at least you have understanding when you are seeing a structure with one oxygen, it can only be aldehyde, ketone, or alcohols. And then the ones that are made up of hydrogens and carbons only, hydrocarbons, we said is alkanes, alkenes, and alkynes. So you are able to differentiate amongst all these structure. And I think we have 3 here that are hydrocarbons. We have 3 that have one oxygen, and we have 2 that have 2 oxygens, and we have haloalkanes, which is said is those are alkanes that have been substituted with the halogen, and then we refer to them as haloalkanes. Now we're saying which one of the following pairs of compounds are functional isomers. Already you check, you know what you are looking for is either you're going to find a carboxylic acid and ester, aldehyde, and ketone. So you check methanol, alcohol. Alcohols, no. Methanol, aldehyde, but not with an alcohol. Butane and 2-methyl propane. You can see there we have 4 carbons. This must be chain isomers. This must be a good example of a chain isomer. Same molecular formula but different type of chain, unbranched and branched. This one, butane is unbranched, and then 2-methyl propane is branched. Now, propan 1-ol and propan 2-ol, you are able to look there and say these are positional isomers. Remember, the good thing about chain and positional isomers is that all these two, the 2 isomers must belong to the same homologous series. So when you see that they belong to the same homologous series, it's either chain isomers or positional isomers. And with these ones, you can see they are all anes, belong to the same family of alkanes. Then you know definitely that these are chain isomers. And then when you see propan 1-ol, propan 2-ol, we're changing the position of the OH. We're changing the position of the functional group. And then we're able now as well to talk to the issue of primary, secondary, and tertiary alcohols or haloalkanes. So we can talk about primary alcohols, secondary alcohol, and tertiary alcohols. And we are saying our primary alcohols, you see this propan 1-ol, you will see if you were to draw it, you will see where the OH is in carbon number 1. So you can see that the carbon that is bonded to the OH, the carbon that is bonded to the OH, remember, OH is not the functional group. The functional group is carbon bonded to the OH. So be careful of your language there. I'm saying the carbon that is bonded to the OH is bonded to one other carbon. That is a primary alcohol. But if I was to move the OH to carbon number 2 in propan-2-ol, OH is in carbon number 2 like that, then it's no longer now a primary alcohol. It's now going to be referred to as a secondary alcohol. Why? Because the carbon that is bonded to the OH is bonded to 2 other carbon. And you can see with the tertiary alcohols as well, when we move now the OH, the carbon that is bonded to the OH must be bonded to 3 other carbons. So you see the difference now. We are always looking at the carbon that is bonded to the OH. Or you can say the functional group, which is your COH, is bonded to 2 other carbons. So that's the different ways of saying it. And then you can now differentiate between primary, secondary, and tertiary alcohol. So we're saying propan-1-ol will be our primary, propan-2-ol will be our tertiary. And then definitely if we have another branch, we can be able to get our tertiary alcohols. Now, the question was, which one is a functional isomer? And then we said we're looking for carboxylic acid and ester, or aldehyde and ketone. And if we check, propanoic acid is a carboxylic acid. Methyl ethanoate is the ester. So you are able to see that this must definitely be our functional isomer. They have the same molecular formula, but different functional groups. All of them O2, all of them have 2 oxygens. And then it's those ones I was saying, Eastern Cape, I was making to remember esters and carboxylic acid as we move. Now, the whole of chemistry is based on this one called periodic table. This one, you must treasure that periodic table is everything that we need. Now, I wanted here to indicate to yourselves, to say, remember we talked about substituents like fluoro, chloro, bromo, and iodo. These group 17 elements here. And we were saying, when we talk about positional isomers, we said these substituents, they can be in different positions. You have seen the substituents can be 2-chloropropane and chloropropane. They will definitely be positional isomers. So you are able to see that these are our substituents. But these are not the only substituents. So I want you to be able to come to the periodic table and write me there, which is now methyl, ethyl, fluoro, chloro, bromo, and iodo. All those are your substituents. Those are your prefix. When we are going to do naming of organic molecules, we are saying all of these, we are going to treat them the same. They are all substituents, and the name will always start with them. As long as there is a methyl, there is ethyl, there is fluoro, there is chloro, there is bromo, there is iodo. The name must start with them, and we must always arrange them in alphabetical order. So I'm saying to you, the preference of methyl, which is CH3 like that, the preference of CH3, which is your ethyl, is the same with the preference of fluoro, chloro, bromo, and iodo. No, we prefer them the same. We treat them, all of them, as substituents, so that you don't have a problem when you do our naming of organic molecules. So it's FCBI for you to remember. It's methyl, it's ethyl, it's fluoro, it's chloro, it's bromo, it's iodo. All those are our substituents, and when they are in the structure, the name will always start with them in alphabetical order, and will indicate even the number where we find them in the structure. So I hope I've clarified that one, because now we're going to naming, and you will always remember what we said. Now, as we consolidate equation 2, we are saying the letters A to E in the table below represent 5 organic molecules. So we're given the 5 organic molecules, and then definitely the questions that you are expecting, the FH gemsine there, not for decoration. To say the F there, you must know the functional group which they belong. You must know the homologous series. The H there is the homologous series. The questions will be about that. Which homologous series does A belong? What is the functional? Draw the structural formula of the functional group of A in that order. general formula, the GE there is for general formula, to say you must know the general formula for all of them. You must know the molecular formulas. You must know the structural formula, condensed structural formula. I can't emphasize this better. You can see most of our questions now, they have condensed structural formulas. So practice as many condensed structural formulas as possible because they can be confusing at times. And then isomers and naming, which is IUPAC naming. So you can see the F functional group, the H homologous series, the general GE for general formula, M for molecular formula, S for structural formula, C for condensed structural formula, I for isomers, and N for naming, which is IUPAC naming. So those are the questions that you're expecting in this section. And we are saying as the strategy, definitely when you look at that structure, you will check what is the functional group. That is the first thing you ask yourself. What is the functional group? You can see we have a substituent called bromo, we have another substituent called CH3, another substituent called CH3. So you can see I'm treating CH3 and bromos the same as substituents because I've already emphasized the me FCBI there to say these ones we're going to treat them the same in a structure. But now, if we never had a bromo here, this will be an alkane, definitely. But because we have a bromo, which is a halogen, it changes the name now to a haloalkane. It's a haloalkane, but halo, we're taking it as a substituent. The same way we are going to treat halo is the same way we're going to treat CH3 and CH3. So if they were to ask you to name this particular structure, definitely you're going to say, when you name, the emphasis is here to say we have the suffix, which comes from the functional group. We have the root, which is the longest carbon chain, and we have the prefix, which is the substituent. So always the name will start with substituents, and I've emphasized for you prefix substituents is this one, me FCBI, which is our methyl, our ethyl, our fluoro, our chloro, our bromo, and our iodo. As we name, those are the ones that will always give preference. The name will start with them. The root is the longest carbon chain. We're going to look at the longest carbon chain. The suffix is the functional group. So which family does this belong to? You said it's haloalkane. Definitely they belong to the family of alkanes. So it's an ane. That is the suffix. Ane is the suffix of haloalkanes. So it's an ane. Root. How many carbons do we have in the longest carbon chain? So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it's hex. So you're able to say it's hex. So it will be hexane. But do you have visitors? Yeah, definitely. We have a visitor from the right. We have a visitor there, which is bromo. From the left, we have a visitor that is methyl. And I told you that these ones, we are referring to them as substituent. We're treating them the same. So carbon number 2 doesn't help us in terms of naming, because in carbon number 2 from the right, we have a bromo. Carbon number 2 from the left, we have a methyl. Hence, we'll go to carbon number 3 to say, let's go to carbon number 3. Maybe it will show us a clear picture to say, where must we start numbering, from the left or from the right? When you start from the right, carbon number 3, this one, there is nothing. It's only hydrogens. But carbon number 3, from the left, there is another CH3. So definitely you can see that from the left, we have the mostly substituted side. So we have more substituents on the left-hand side as compared to the right-hand side, irrespective of bromo being in terms of alphabetical preference, bromo being B. Definitely when we prefer, the first thing we prefer is the functional group. Number 2, we look for the mostly substituted side. And the mostly substituted side is the left. So this is carbon number 1, number 2, number 3, number 4, number 5, number 6. I hope I've clarified the issue of bromo and chloro belonging to this family, to say we are treating them the same as substituents. And then we are saying we are starting from the left because on the left we have the mostly substituted side. I think I've emphasized that. We have moved together. So you are able now to see that, okay, in terms of the naming, we'll definitely have bromo is in carbon number 5. So definitely this structure will be 5 bromo, A, B, C, D, when we're writing the name. In carbon number 2 and number 3, we have methyl. So that is 2, 3 dimethyl. 2, 3 dimethylhexane. Remember, the name is one name. You see, I've never used any capital letters there. Just write small letters, name. Don't forget, unlike terms, a letter and a number, there must be a hyphen. A number and a number, there must be a comma. So like terms, comma, unlike terms, hyphen. Please have that in your mind. And one name is only esters and carboxylic acid that will have space between the name, like your hexanoic acid, methanoic acid. There is space between the hexanoic and acid, but all the other homologous series is only one name. No matter how long it is one name. I hope this will help you as you do lot of naming questions. And we are saying, when you get a structure that is given as like that, as a molecular formula like that, C3H8O, please first draw it. You will be so amazed when you look at it. You can see something, can't you? When you draw it, you find that it's different. Remember, when you see 3 saying draw 3 carbons, and then these 3 carbons, there are 8 hydrogens, so you allocate the hydrogens. Remember, each carbon must have 4 bonds, so it's 3, 4, 5, and then you are able to see 6, 7, OH, number 8 hydrogens, there are 8. So you can see it's an alcohol, but without drawing it, you can make a mistake of thinking maybe it's an aldehyde or a ketone or something. So please draw it in order for you to know definitely that this must be an alcohol. And then on this one, you can see we are having an ester there. We are having an ester, and I'm saying please remember the process esterification. We are saying that always formed from an alcohol. In this case, we're using primary alcohols plus carboxylic acid, and then we're saying alcohol plus carboxylic acid form ester and water. And we're saying when you see water, know that sulfuric acid, which is our dehydrating agent, sulfuric acid will be our catalyst. So always have that, and heat as well will be very much important. So know that we are having an alcohol. The alcohol will always, the alkyl part, you can see that this part that is the C double bond O will always come from the carboxylic acid. So the one that is a C double bond O will be coming from a carboxylic acid, and the one that is an alkyl group without a C double bond O this side will come from an alcohol. Because the question can be, this ester, was formed from which organic molecules? So you're able to see, okay, this one is an alkyl group, the one without the C double bond O, you see that must be propyl, and propyl is from propanol. So you can see that we had propanol, and we have 1, 2, 3, 4 carbons, so the acid was butanoic acid. And we are saying, don't forget the conditions. We are saying sulfuric acid and some heat there. And then we are saying this will give you propyl butanoate. And we said there is a space, 2 names, propyl butanoate. And then you are rolling. You are able to do all that, and then you are getting all your marks. Definitely expect a question on esterification. So you can't go to the exam without having that understanding. I hope all these have shown you what is to be expected of you in terms of question 2. Now, when we look at our physical properties, remember I've emphasized here that we have 3 physical properties, which is your melting point, vapor pressure, and the boiling point. I put them intentionally in that order because we are having a solid that must become a liquid until it boils. Now, our melting point, we said it's not a point, it's a temperature at which the solid phase and liquid phase are at equilibrium. Solid phase and liquid phase are at equilibrium. So we have 2 equilibriums here, the one at for melting point and the one for the vapor pressure. Remember, vapor pressure was saying is the pressure exerted by vapor at equilibrium with its liquid. So it's a pressure exerted by vapor, at equilibrium with its liquid in a closed system. For this one, you must say closed system because the molecules now have higher kinetic energy and can escape if we don't close the system. So it must definitely, this one must be in a closed system. So we have the first equilibrium where we don't mention closed system. Second equilibrium of vapor pressure, we mention it. And we are saying now boiling point is a temperature gain at which this vapor pressure that we're talking about now is equal to atmospheric pressure. So it means the vapor pressure increases until it reaches atmospheric pressure. Remember, atmospheric pressure we said is 101.3 kilopascals. It is given on your table, and then you are able to have that. And then we are simply saying your water will boil, or your molecules will boil when the vapor pressure is equal to 101.3 kilopascals. Remember, we can use 101.3 kilopascals, or we can use 180 M. So those are three physical properties. And then for this lesson, I will want to minimize the number of independent variables that we are going to have factors affecting three physical properties. We have three physical properties, and we are saying there are factors that affect them. And the factors that are for this lesson I want to focus on is your intermolecular forces, to say intermolecular forces definitely. And for our syllabus, you will see that if we change the functional groups, you'll find that we are changing the intermolecular forces. So I will restrain it to intermolecular forces as the first factor that will affect these physical properties. And then we have now again our chain length. We have our chain length. As the chain length increases, the boiling point and the melting point will increase. Why? Because the strength of intermolecular force increases. And then we're going to look at the branches to say as the number of branches increases, the strength of intermolecular forces decreases. Hence, you'll have as the branch increases, you'll have a lower boiling point and melting point. And don't forget that if you were to deal with that, you definitely, if you have more branches, you're expecting that now you have the highest vapor pressure, because vapor pressure increases as the strength of intermolecular force decreases, whereas melting point and boiling point increases with increase in the strength of intermolecular force. We're always emphasizing here, don't use directly proportional. Just say as the melting point, as the strength of intermolecular force increases, melting point and boiling point increases. As the strength of intermolecular force decreases, vapor pressure increases. Have that and refrain from using directly proportional. So I hope I've summarized it nicely for you. And then already we said we are dealing with the independent variable and dependent variable. The independent variables, those are our independent variables. Our dependent variables are the three physical properties, which is melting point, boiling point, and vapor pressure. If you get a question that says, what is the dependent variable, is either melting point, boiling point, and vapor pressure. In this case, our dependent variable will be boiling point. Our independent variable, what are we changing? We are changing the number of carbon atoms, which is our chain length. So you are able to see that that is the case. And then as well, when we move here, we're able to check as well the independent variable changes as it changes, and then the dependent now there will be effect. As long as we change the other factor, the factors that affect the physical properties, definitely there will be effect that will have there. For an example here, we're given number A. Look at A there. We're having that structure, which is 1, 2, 3, 4, 5. We're having pentane. We're having 2-methyl butane. We're having 2,2 dimethyl propane. So definitely you can see we're increasing as we move from A to B to C. We're increasing. These are the trends. We're increasing the number of branches. What is the effect of increasing the number of branches? As we increase the number of branches, the vapor pressure increases. And you know definitely that vapor pressure increases with the decrease in strength of intermolecular force. I'm always emphasizing that one so that you don't make mistakes. Now, in terms of how you are going to answer questions, we are saying the main thing you have to explain the difference. So I usually will say here, you can just use what we call dice for you to remember. The dice there, I'm simply saying, look at what is different. What is different? And then look at the strength of intermolecular force and the energy required. So we're saying, look at what is different. And then what is different, we said, is our independent variable, what is changing. And you look at the strength of intermolecular force. Is it stronger or weaker? Intermolecular force, write it in full. And the energy required to overcome the intermolecular force. So if you have all that, you are ready to go. You can answer any question because you can be able to show for A and for B, and then you are able to answer the question to say, okay, what is the AB? Let me write it here. What is the difference? Remember, on the difference, you are restricting yourself to your intermolecular forces, your chain length, and your branches. And then you are able to say, what is different? This one is a longer chain length. This one is a shorter chain length. What is the strength? Then you are able to say the one with the longer chain length has a stronger intermolecular forces. The one with the weaker, with a shorter chain length will definitely have a weaker strength of intermolecular force. And when it comes to energy, if the strength of intermolecular force is high, definitely less energy will be required to overcome the intermolecular force. So if you have that dice table there, you are able now to go and answer this question. And we're saying you can do like that, or you can do in bullet forms. What helps with bullet forms is that we will definitely look at those bullets independently. So that if you are writing a paragraph, you are explaining a wrong concept, everything is wrong. But when you are writing in bullet forms, we'll read the bullets like that. And always look at the number of marks, because it will tell you how many points we're expecting for the question you are answering. I hope this helps you as you answer questions. And then to look at an example here, to say we're given 4 compounds A to D with your propane, your butane, your butanol, and your butanol. So it's very much important for you to have that understanding there. The first question was define the term melting point, and already we've emphasized that melting point, we're talking about equilibrium. We said it's the temperature at which the solid phase and the liquid phase are at equilibrium. And then we're saying the melting points of A and B are compared. And then write down the independent variable. What are we changing between A and B? Already you know. We said if chain branch, for you to remember, if chain branch. So is it intermolecular force that is changing? No, they have the same intermolecular force. They all have London forces. Is the chain length that is changing? Yes. Propane, shorter chain length. Butane, longer chain length. So you're able to see that independent is what are we changing? We're changing the chain length. So the molecular mass is definitely different. And then the question will say, indicate the difference. You're able to do that. So as given, define melting point, you're able to define it. And then melting points of compounds A and B are compared. And then we said the independent variable is your chain length. Definitely is a chain length. But even if you said the number of carbon atoms, we'll accept that one, or the molecular mass. But it's even much easier when you just talk to the chain length, which is in our exam guideline. Now, explain the difference in melting points of these 2 compounds. You see, that is 3 marks. It's channeling you now to say, okay, you have told us about the different, and then you are going to say, talk to the strength. So always acknowledge the intermolecular force, to say all of them, they have London force. All of them, they have London forces. And then because it's alkanes, all of them, they have London forces. And then you are saying a butane has a longer chain length compared to propane. Longer chain length than propane for butane. So you refer to them as B. B has longer chain length than A. And then in terms of energy, more energy will be required. The one that has a longer chain length, definitely it will have a strength of intermolecular force will be high. So which means now you are saying the strength of intermolecular force in B is higher or is stronger. So B has longer chain length, so it has a stronger intermolecular force than A. And then if it's stronger, more energy. Remember, you're going to face a stronger somebody, you must have more energy to overcome the intermolecular force. So always be in that structure, use your dice, always look at what is different. But in terms of intermolecular forces, I will advise you to always acknowledge your knowledge, to know that, to show that you know that both of them have London forces or has dipole, as indicated to say AAA, all of these, they have London forces. Hague, all of them, they have dipole. And then AC, your alcohols and carboxylic acid, they have hydrogen bond. Remember, alcohol have one side for hydrogen bonds, and then carboxylic acid have two sides. So carboxylic acids are the strongest of all the intermolecular force. I hope that will help you as you go on in answering questions. So now, just to complete this question, to say the melting points of compound C and D are now compared. C and D, you can see different functional groups. Definitely, if the functional group are different, we'll be talking about different intermolecular forces. So when you respond to this one, you're going to tell us that, okay, when it comes to butanol, it has dipole. When it comes to butan 1-ol, it has hydrogen bond. And then you come and tell us about now, that is the difference between them. The difference is that the other one is dipole, and then the strength of intermolecular force, the S there for your dice, is to say now strength, definitely hydrogen bonds are stronger. So you are saying D has stronger intermolecular forces than C. And then you are saying because they have stronger intermolecular forces than C, you got the energy required to overcome the intermolecular force. You are saying more energy will be required for D to overcome intermolecular force in D than in C. So I hope that will help you, and you'll be able to collect all those marks that you expected to collect under that question. Organic reactions. Already I've emphasized the importance of these three homologous series: your alkanes, your haloalkanes, you will see when you look at the question, and your alcohols. If you understand these ones, most of the things will be much easier for you, because you know, don't forget alcohol, alkanes, haloalkanes, and alcohols. And we are saying these, they can undergo substitution and elimination. So when you see those, you think about substitution or elimination. Remember, in addition to that, for alkanes, they can undergo as well your oxidation, your combustion reactions as well in terms of that one. So you have to always remember that. But in the most important thing, and as well your alcohols, esterification, they can be involved in esterification as well. So you're able to have that. But you know that all, when I see alkanes, haloalkanes, and alcohols, I will know that these two reactions I must think about, which is my substitution and elimination. Now, without wasting time, let's look at your USA. When you have unsaturated forming saturated, we are saying it's addition. When you have saturated forming unsaturated, we are saying it's elimination. And when we are having saturated forming saturated, we are saying it's substitution. And we are saying the condition is everything. When we have CDS here, we are simply saying concentrated is for elimination, dilute is for substitution. And then you definitely have to have that one.